All right, everybody watch. We're going to start with inscribed circle. And actually, let's do this. Let's start with a circle we've talked about, or an angle that we've talked about before. Just to remember, I'll do this in red just to set it apart a little bit. What if I had, oops, I just made that red. Let's try this again. All right, now I'll go to red. Now it should work. All right, what if I did this? Tell me what this thing is. If I went from here to here, this is something we've talked about already. What is this angle called right there? What's the name of it? A special name to it? Say it. No, this angle right here. What's the name of this angle? Say it. No, we don't say minor angle. What is it? No. Ah, come on. We talked about it. Where's the vertex? Where's the vertex of this located? It's at the center of the circle. So what's the angle called? What?
Center angle?
Not center. Come on.
Central.
What? Central angle. Did we not cover that? Yeah, I think we did.
Close.
I think we did. All right. Come on now. That's not too hard. This is called a central angle. We even wrote it down and everything. I remember absolutely doing this. Okay. You can look it up now. See? Say now I got something to hold over your head. See now. All right. So this is a central angle right there. Now, I expect you to know this. If this was 30 degrees, and this was arc AB, what's arc AB going to equal if that's 30 degrees? It's going to be 30 degrees. The central angle is equal to the arc that it cuts off, or we say the intercepted, are you listening to me? The intercepted arc. So look what this angle does. It hits here at A, hits here at B, creates this arc right here. So this angle is equal to this arc. So that is going to be 30 degrees. You with me? That's just recall, right? I mean, that's just, what do you call it? Review. Should be review. So let's get rid of that. Don't want to delete the circle. And let's get rid of this, that, and that. All right. Now, what we're going to do now is not do a central angle. We're going to do another kind of an angle. Where was the vertex of that central angle? At the center of the circle. Okay. This time, the vertex of my angle is not going to be at the center of the circle. It's actually going to be right on the circle. All right. So here's the vertex of the angle. So if I go from here to here, and it goes to the other end of the circle, touches the circle, and it goes from there to there. This time, this angle right here is not a central angle. Remember, a central angle, where is the vertex of the central angle? At the center of the circle. This time, the vertex of this angle is where? On the circle itself. We did something a couple days ago. Remember that day the baseball guy came in and Mrs. Swam came in, and I was in the middle of doing this, and I did like 4 sides, and they all hit the circle. Do you remember what I called that thing? Inscribed. Very good. It's just inscribed. I think it was an inscribed quadrilateral. I think I did 4 sides. Do you remember that? So it was an inscribed quadrilateral. What was true about the vertices on each of those? They weren't congruent. They were on the circle itself, right? They were right on the circle. Same thing here. Look at this vertex. See the point right there? That's right on the circle, isn't it? All right. So we call this, now that was called an inscribed polygon or an inscribed quadrilateral. So what do you think this angle is going to be called? Inscribed angle. Good. And what makes it an inscribed angle? Well, the vertex has to lie where? On the circle. Okay, not in the circle, not outside the circle, not on the, not at the center. Okay, actually somewhere on the circle. You got it? Now, there's actually a relationship between this angle right here, the inscribed angle, and the arc that it cuts off. Right? I'm going to try. It's kind of big. Try to see how steady I am. Oh, I'm getting better at this, aren't I? It's not bad. Okay, so we've got an inscribed angle. I'll just kind of highlight it so you can see that arc right there. So here's the arc that's cut off by this. Now, if you remember, I almost hesitate to do this, but I just don't want to dirty it up too much. But remember, we just talked about this. That blue one right there. What's that blue one called again? We just talked about it. That's the central angle. Okay, what's true about the central angle? It's what to the arc? It's congruent. It's equal to the arc. Okay, so if this is arc AB, this angle right here is equal to this. Now, do you think this inscribed angle is going to be equal to the arc? What do you think's happening? It's gonna. Yeah, you looked, didn't you? All right. So it's going to be exactly half of this arc. All right. Now, you couldn't just look at it and say, oh, yeah, I know that's half. I mean, you know, it might look like it. I don't know. If you look at this angle right here, you could look at it and compare them and figure out that, yeah, it is half of this. All right. So let's just make up a number. Let's say this arc right there is about 80 degrees. That looks pretty close. It looks almost like 90 degrees, doesn't it? Okay, well, we'll just make it up and say it's 80 degrees. So if this is 80 degrees, this angle in here is the central angle, so that has to be 80 degrees as well. We got that? Central angle is equal to its intercepted arc. But the inscribed angle, if this is 80, what's this angle right here going to be? This is going to be 40, exactly. And that's really the main thing about an inscribed angle, right, is that it's half of the arc that it cuts off. Of course, it could go the other way. I could give you the angle, couldn't I, and ask for the arc. So if this was 40 degrees, then the arc would be how much? It would be double, right, which would be 80 degrees. You see that? So obviously they could give both ways. They could give you the arc, you need to find the angle. They could give you the angle, and you need to find the arc. Make sense? All right, let's go on to another type. All right, this time we're going to do inscribed angle again, but we're going to do two inscribed angles. But I want you to see what both of these inscribed angles do. One goes to here. I'm just making up a place, just random place, you know, nothing specific about where I ended up right here. I just decided to go right here. Now I'm going to draw another inscribed angle. So I'm going to change the color of it. You could put that anywhere. You could start here, you could start up here. It doesn't make any difference. Let's just, I don't know, just making this up. Let's start, oops, oh, what am I doing? Why is that box around there? Let's Control Z. There we go. Now I went too far. Oh, goodness. Let's do this again. Where was I? About right there? Doesn't really make any difference. All right, let's get out of this. Now we can change the color. And now I go to my line tool. Now we should be good to go. Watch, I'm going to go anywhere here. Let's say about right there. And what I'm going to do, now I'm going to be specific about this. I'm going to take my inscribed angle and go right to that point, and I'm going to take this and go right to this point right there. Now let's think about what's going on. And we can kind of figure this out on our own. You see the blue one? You see the red one, right? Let me just put the little angle symbol right here for that. And let's put the blue one. Which blue? Was it that one or that one? Is it that one? Doesn't matter. For that one. Okay? All right, now watch what they're doing. Look at this blue arc right here, this blue angle. Where does it hit? It hits right here. We'll call it A, B. See what it does? It cuts off that arc, AB, right there. Well, what does the red angle do? Cuts off the same exact arc, right? Let's just make something up. Let's just use 80. We used 80 before. Let's just use it again. It's a nice, easy round number to work with. If this arc AB, sometimes they do this. Okay, and then you'll see arrows there just to show you. But if they just stick at 80 between the A and B, that automatically means it's 80. Sometimes people like those little things. If this is 80 degrees, what's this blue arc right here? Or the blue angle, I should say. What is it? It's 40, isn't it? All right. If that's 80, what's the red one going to be? It's going to be 40 as well, because it cuts off what? The same arc. Do you see it? So they're both cutting off the same arc, so they both have to be what? Half of the same thing. So if they're half the same thing, what must be true about the relationship between the two of them? They got to be equal to each other. So if I call this angle C and angle D, then if you have two intercepted, let's say this, two inscribed angles, right, that cut off the same arc. You with me? And that's what they do, right? The blue one and the red one, they cut off the same arc, AB. If you have that situation, what must be true about those two angles? They have to be equal to each other, right? And we just kind of showed you in a little proof-like way, it's not really a proof, but a proof-like way, why those two are equal to each other. Make sense? I could have just sat there and said, okay, they're equal to each other, and you'd say, well, why would that be? Or maybe you're saying, I don't really care why, just show me how to get the answer right? But hopefully you want to have a little bit of understanding of why they're equal to each other, and that's exactly why they're equal to each other, because of what we just showed. All right?